Welcome back to this Java Intermediate Level course. We are still in session 1. However, in this video we are going to discuss sorting. We will cover the introduction to sorting algorithms, the selection sort, the insertion sort, and the merge sort. So the selection sort is a simple sorting algorithm. This sorting algorithm is an in-place comparison algorithm. It divides our list into two parts, and the sorted part, I guess you could say, on the left end, and the unsorted part on the right end. And initially the sorted part is empty and the unsorted part is the entire list. The smallest element is selected from the unsorted and swapped into the leftmost, and the element becomes a part of the sorted array. This process continues, moving the unsorted array boundary by one element to the right. This algorithm is not very efficient. It iterates through all of the members of the list several times. It's not really suitable for large data sets, and because its average and worst case are complexities of big O of n squared, where n is the number of items in the list. So the amount of processing this would have to do would be quite long. If we take a look at a summary of the steps for the algorithm, we set the minimum location to 0. Search for that minimal element in the list. That's what we want to search for first. Swap it into a part of memory for that location and declare that to be the min. And then increment the min to the next element and repeat until making that comparison until the list or the data structure is sorted. And we can see here with the pseudocode, we have the list, and we have the size of the list, and we have that data structure here, and then we have a for loop. So we set the current element as a minimum, so whatever that is pointing to, and then we use our loop and iterate through comparing the current element to the minimum. And then if we have a less than, if that's true, then we have a new minimum. And then we swap the element with the current element if it is if the index is minimal, and then we just completely iterate through the list. So here's something to try out. Here's an example. We have our selection sort class with our main method here. And we also have our print array here too. You can see this one is iterating through the array and printing out the array. As we can see, our array is right here, and we can see that our selection sort object is right here. It's of type selection sort, so OB. So OB calls sort, and we can see sort is up here. And we print out sorted array, and we print out that array. So we're also calling print array as well, which is right here. As we call sort, we get the length of the array, which is right here, which is passed in. We find the minimal element in the unsorted array, and we iterate through that. We swap the found minimum element with the first element and continue to sort the array until it is the minimum is to the minimum is found, a new minimum is found, and then everything that's larger than that is ranked above those minimums. And then you can see here this list, which is, or this array, which is obviously unsorted, will be printed as sorted. The insertion sort is another sorting algorithm. Here it's an in-place comparison-based sorting algorithm. A sublist is maintained that's always sorted. For example, the lower part of the array maintained to be sorted, and an element which is to be inserted in this sorted sublist has to find its appropriate place, and then it's inserted there, hence the name insertion sort. So a list is already sorted, and then the new element, the correct place is found, and that element is then inserted into the array. So it's more efficient. So the array is searched sequentially, and unsorted items are moved and inserted into the sorted sublist in the same array. And the algorithm, again, is not suitable for large data sets, as its average worst case complexity, again, is big O of n squared, where n will be the number of items. So the bigger the list gets, the longer this is going to take to run. Here again are the algorithm steps. If it is the first element, it's already sorted, so just return 1. Pick the next elements, compare to all the elements in the sorted list, shift all the elements in the sorted sublist that's greater than the value to be sorted, and insert the value, and then repeat until the full list is sorted. So that's the idea. It's looking for its proper place and then shifting everything else, shifting a place in the array. And we can see here the pseudocode for it. Again, we make our declarations, we have our for loop here, and we are searching the values and finding locating a position for the element to be inserted, and you can see the logic here, and then we insert the number at the proper position. So now we can take this pseudocode, once we have this logic working for this insertion sort, and we can move it to actual source code. So with the actual source code, again, we can see we have our class insertion sort, and we have our method, our main method here, where we are actually instantiating the sort. We also see we're calling print array on the array, and we can see the actual array here. So as we see here, we're calling a sort, and here's our sort function here. And again, we're moving the elements of the array that are greater than the key, and we're declaring our key up here. Again, we have our for loop, we have our key, and we are moving elements that are greater than the key to one position ahead of their current position. So we're actually going through and finding where the elements should be. So we're going through this one at a time. And then while this element of the array is greater than the key, we are going to swap their positions. And then we'll be leaving the loop, and we'll be declaring a new key position. And if we come down here, we see once we complete that sort right there, we'll print out the new value of the array. So try this. You can again enter it into your integrated development environment, or you can just enter it into Notepad. Another popular sort is the merge sort. So the merge sort is a technique based on divide and conquer. The worst case time complexity being big O of n log n, which makes it a very efficient algorithm. The merge sort first divides the array into equal halves and then combines them in a sorted manner. This is best illustrated if we take a look here at this pseudo logic. So we can see here merge sort as var A. And then we see it down here, var A as array, and then var B as array. And then we can see var C as array. So the whole idea here, and here's where the logic is happening, using the while loops to test for greater than or larger than, and then do the resort. So the once the test is done, the changing of the element places is done. So that is what is going on as far as the merge sort. The merge sort is using this divide and then evaluate. Let's take a look at the following set of steps for the merge sort. So first we have this array of 8. So obviously this array is unsorted. And with the merge sort first divides the whole array into 2 equal halves. We see it's an array of 8 divided into 2 subarrays of size 4. And so far, no sequences have changed. And then what happens is the 2 arrays of 4 are then divided in half. And now we have 4 arrays of 2. And finally, they're broken down one more time. Then the smaller arrays are recombined, only this time each of the smaller arrays is evaluated and sorted. So we see the 14 and 33 are evaluated and sorted, the 10 and 27 are evaluated and sorted. So when we take these subarrays and then combine them back, we can see here that now we have a sorting of these subarrays into their sort order. And then finally, after merging, we have this full sort with all of the aspects of the numbers in their correct order. So the merge sort is a sorting in an iterative approach. So it breaks into smaller arrays and then recombines while sorting. So it sorts in a iterative manner. So here's an example of the coding of the merge sort algorithm. First here we see the merge method, and we see the sort method here. With the merge method, we see that first there are the subarrays, and we see that the subarrays are then each evaluated for sorting. So whichever element, whichever index is smaller gets repositioned. And then we actually there here call the sort of the arrays. And we are able then to call the merge right here on the arrays. So we can see here how they get broken down and they get merged again. So a good exercise would be to key in all of this code here into your IDE and enter an array and try to walk through it line by line. Perhaps use the visual debugger. It's a great way to understand how this algorithm is running in Java. So let's use what we just learned, all the different sorts, and let's try one of them or more of them and try to find the answer in this assignment. So we see here these 2 arrays. They're the same array. One time we are looking for the k, well, we are looking for the k smallest. So one time we're looking for k equals 3, so the third smallest. The output should be 7, and that makes sense. It looks like 7 is the third. This is the 3 is the first smallest. 4 is the second smallest, so 7 is the third smallest. So we get the output of 7. And same thing here. We want to get the fourth smallest. And again, 3 is the first, 4 is the second, 7 is the third, so 10 is the fourth. So try this. Try to do the sort and then find the position of the third smallest and the fourth smallest. So just go back through what we just learned, use the examples that you saw, and I'm sure you'll find that it's very, very interesting how the sorting and possibly the search can work. So what we discussed in this session, session 1, we discussed searching applications and sorting applications. Our next session is going to be the fundamental data structures. So dynamic memory allocation, linked list, stacks, queues, and trees. And these are all examples of what we call data structures. Live private coaching sessions for Java are available. Please consult your learning materials. And this this session has been a presentation of coding boot camps. Thank you for watching this video.